Okay, geometry students, we are back. All right, independent practice, Thursday. Let's kick butt. Okay, so here we go. What is the lateral area? Oh, thank God, I don't have to find the surface area. Of a traffic cone with a radius of 10 inches and a height of 28 inches. Round to the nearest whole number. Good, we don't have to worry about keeping it in terms of pi. I don't have to worry about the complete surface area. I just have to worry about the cone itself. Everyone's seen one of these traffic cones, right? If you've been around the New York City area, there's literally probably billions of these in New York City. Right? I bet you there's one for every citizen. Okay, I've seen them so many times. So, what are we going to do? Okay, we got to figure out here the surface area. Okay, that's not bad. Okay, so the surface area of a cone, the lateral surface area of a cone is just, remember we just did this a little bit earlier, is just pi r being the radius and L being the slant height. Now, the problem with this is going to be the L. With this problem, they're telling us the height, which is the top here to the bottom. I want the height going down. Imagine getting on like a skateboard or a pair of skis or something and sliding down that like mountaintop. I want that height. I don't want the height from here to here. Okay? So to give you a better example of what we're looking at, I'm going to use the example from the other one. I need to find L. They're giving me height. And they say the height here is 28 inches. And they say the radius is 10 inches. Oh, wow. Okay. Once again, this comes to a major problem. We're going to have to use a little trick here. We're going to have to figure out L. This is a right triangle, so for this, I'm going to be doing this here. I want to find L. So to find L, we're going to use good old Pythagorean theorem. Now, I can make either one of these A and B, so I'll go 10 squared plus 28 squared. Remember, this is the hypotenuse because it's across from the right angle. I'll call it L squared, just to make things interesting, because that's what we're solving for. L squared is definitely the hypotenuse of this one. So 10 squared is 100. 28 squared is not what I have in my mind, but I'll check it out. 784 equals L squared. Now, 100 plus 784, that I can do without a calculator. Now, to solve for L, I have to square both sides. Or square root of both sides, not square both sides. L squared is just L. And 884, the square root of 884, if my mind is turning to mush, is 29.7. I'm gonna keep it at 29.7. Because we're not really done with the problem yet. I don't want to round it just yet. Bring too much rounding error, I think. Now I come back here. Well, I have all this information now. LA equals pi. I can use 3.14 if I don't know how to use pi on my calculator. Times R, which we already found out is 10, times the lateral, the slant height, or big little L, which is 29.7. That's it. I'm going to they say round to the nearest whole number, so they don't say keep it in terms of pi, so I got to do a little bit more work. Okay, the number's going to be a little bit messier. Round to the nearest whole number. Okay, so let's do this first. Second, pi times 10 times 29.7, close parentheses, and I get this. 933.05 is our lateral area. I look at this next number because I have to round this to the nearest whole number. So I don't want to have any decimals. This is 0. If it was 5 or more, I raise it, but it's 0, so I keep it there. So the lateral area of this traffic cone is 933 square inches. Or you can write it inches square. All right, good job, guys. Hopefully this was a little bit easier than the last two. All right, one more set coming tomorrow. All right. Oh, there it is. Hopefully I didn't. You got that? Okay, good.